Today we're going to be moving on to graphing rational functions with wholes. So let's start off with this function right here. Our first step is to factor, just like before. So our numerator stays the same. Can't factor x minus 1. But our denominator, we can factor out. Let's use our x box. So we'll multiply to give us -3, adds to give us 2. It's going to be 1 and a 3. We want one of them to be negative, and it's going to be our -1 so we can get a positive 2. So we can rewrite our denominator as x minus 1, x plus 3. So looking in our denominator, we know our domain is x cannot be equal to +1 and -3. Now let's take a look at what's happening to f of x near 1. So as we approach 1 from the left, look at what f of x is getting closer and closer to. It's getting closer and closer to 0.25. If we look at as x approaches 1 from the right, the f of x is also getting closer and closer to 0.25. So notice how they're both getting closer and closer to numbers. So this is actually not an asymptote. We don't have an asymptote at 1. Whenever we have a common factor, so this means that we have it both in the numerator and the denominator. So we have x minus 1, the numerator and the denominator. This produces a hole in the graph. So it's not going to be a vertical asymptote anymore. Now it's a hole. And so in this case, our hole is at x is equal to 1. So we're going to reduce our function. So before it was x minus 1 over x minus 1, x plus 3. But we can cancel out the x minus 1 and the x minus 1, which leaves us with 1 over x plus 3. And so we know our hole is at x equals 1. And to figure out where the hole is, we're just going to plug it into this equation. So we're going to do 1 over 1 plus 3, which gives us 1/4. And so our hole is going to be at, our x is 1, our y value is 1/4. So today we're going to be graphing some rational functions where we might have a hole in the graph. So let's take a look at, so this exact same equation, we're going to go through the entire steps for graphing this function. So we already factored out, we know on top x minus 1, we know on bottom it's going to be x minus 1, x plus 3, because this is the exact same problem we just did right here. So we know our domain is x cannot be equal to 1 or -3. Now again, we can rewrite this as the x minus 1's cancel out, so it's really just 1 over x plus 3. So whenever you can cancel out, because it's on the top and the bottom, this is going to be where our hole is located. So we know our x value is going to be 1. And our y value is when we plug 1 into this equation, so 1 over 1 plus 3, which is 1/4. And so now our vertical asymptote, so because we have a hole at 1, our vertical asymptote is the one that we have left over. So x is equal to -3. So again, it's just the zeros of the denominator. So let's draw a vertical asymptote at -3. 1, 2, 3. Now we're going to draw a horizontal asymptote. So we're going to try to divide. So when we divide x minus 1 over x squared plus 2x minus 3, can we divide x by x squared? No, we can't. So it's already in proper form, which tells us that our horizontal asymptote is y equals 0. So again, we're going to plot this at y equals 0. And so we can actually graph, before we do our x and y intercept, we can graph this point. So 1, 1/4 is going to be the point that we're graphing a hole, which is going to be an open circle. So we go over to 1. 1/4 is going to be a fraction, so just slightly above 1. This is going to be an open circle where my hole is located. Okay, then for my x-intercept now, it's just like before. You're going to do numerator equals 0. We're going to use the reduced fraction, so our simplified fraction. So in this case, 1 equals 0. Is 1 ever going to be equal to 0? No, it's not possible. You can't solve that equation, so there's no x-intercepts. For our y-intercept, we're going to plug in 0, so this is now when x is equal to 0. And we're going to use, again, our simplified fraction. So we're going to do 1 over 0 plus 3, which gives us 1/3. So my y-intercept is at 0, comma 1/3. And let's plot this. So 0, 1/3 is going to be a point, again, a fraction. It's going to be a little bit above this point. Okay, so now that I'm done plotting all these points, I'm going to do my sign analysis. So on the left of -3, let's pick a number to plug in. Let's use -4. We're going to plug it into our simplified fraction because that one's going to be easier for us to do. So 1 over -4 plus 3. This is a positive divided by a negative, which gives us a negative. So we know that this entire graph is going to be underneath our asymptote. It's going to look like this. For this section, we already know because of these points right up here that this is going to be positive because these points are positive, and we know we want it to go towards the asymptote. So it's going to go up and go through, connect to the hole, and then go down towards this asymptote. So this is my final function. So all the steps are the same except for the initial one where we have to find if instead of an asymptote there's a hole in the graph. Okay, let's move on to one more example. So flip to the back. So again, we have to start off by factoring. So this one is a little bit different to factor. Let's take a look at the numerator. To factor this one out, we're going to start off by seeing if there's something you can divide out of all three of those terms. There is, you can take an x out of all those terms. All right, so that leaves you with x squared plus x minus 12. Notice in the denominator is very, very similar. You could also take out an x here. So x squared minus x minus 12. Now we can factor this even further because these are trinomials, so we can use our x factor. So what multiplies to give us -12 adds to give us 1, 4, and -3. So this is x plus 4, x minus 3. And on the bottom, we want two numbers that multiply to give us -12 and add to give us -1. So this one's going to be -4, positive 3. So x minus 4, x plus 3. So clearly, you can see our common factor, the one that we can cancel out, is this x and this x. So these two can cancel out. So for our domain, it's everything in the denominator. So we have x does not equal 0, so 0. Right, so x minus 4 doesn't equal 0, so that gives us a positive 4. X plus 3 is going to give us a -3. So all three of these are in our domain. But the common factor, the one that we can cancel out from both top and the bottom, that's going to tell us where the hole in the graph is. So that one is at x is equal to 0. And to figure out the y value, we're just going to plug it into the rest of our equation. So now that these have canceled out, if I plug in 0 to the rest of my equation, this is going to give me 4 times -3, which is -12. -4 times 3, which is -12. -12 divided by 12 gives me 1. And so I know that there's going to be a hole at 0, comma 1, and that's where my open circle will be. Okay, so our vertical asymptote are then my other numbers. So I have x equals 4 and x equals -3. So let's draw that on our graph. We're going to divide to find a horizontal asymptote. And we could divide with either this one or this one, but we don't want the factored form. So we're just going to divide x cubed divided by x cubed. Number divided by itself is 1, so this gives you a 1 up here. We don't even need to find the remainder, but we could if we wanted to. And our y value is just equal to 1 for our horizontal asymptote. So those are my asymptotes. Again, I'm going to draw my holes at 0, 1. 0, 1 is right here on my y-axis, so that's where my open circle is going to be. Let me find my x-intercept. So numerator equals 0. My numerator is x plus 4, x minus 3. Alright, so we're using this one. We're going to solve, so we're going to have two answers here. X is equal to negative 4 and x is equal to positive 3. So I have two x-intercepts, negative 4, comma 0, 3, comma 0. So I'm going to plot these. So negative 4 is right here. 3 is right here. And now for my y-intercept, I'm going to plug in 0 for all my terms. So I actually already plugged in 0 for my terms right here, right? Because at 0, it's going to give me 1. But 0, comma 1 is actually our whole. So we don't need to plot a point there because we already have our point. It's an open circle. So all that's left to do now is our sign analysis. So this section right here on the left side of negative 3, because of this point here, we don't need to do sign analysis. We already know what this side is going to look like. It's going to approach our asymptote in both directions, so we already know that one. So on this side of the 4, let's just do this side on the outside first. So let's pick a number over here. Let's say 5. So we pick f of 5. We're again using our simplified factored form. So 5 plus 4, 5 minus 3, 5 minus 4, 5 plus 3. And this is going to give us positive, 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 positive. So positive over positive is just positive. So this entire section right here is going to be positive. So we know it's going to be up here. And now for the middle part, we know that these 2 points have to connect. So let's draw a line connecting these two. So here's my x-intercept at 3. So because of this point right here, this 0, 1, I know that this section is going to be positive because that 1 is above the x-axis. So the rest of this should be going up as well. And for this section, let's just make sure that this one, if we plug in 3.5, so 3.5 plus 4, 3.5 minus 3, 3.5 minus 4, 3.5 plus 3. So this is going to give us positive, positive, negative, positive. So it's a positive divided by a negative, which is negative. So this section between 3 and 4 is going to be negative. So I know that this section should be pointing down towards my asymptote. And this is my final graph.